The quicker I get through it, the more time you have to do your two problems today. So our goal is to write quadratic equations without a vertex or an x-intercept. So last week, given a vertex, we went into vertex form. Given an intercept, we went into intercept form. Today we got none of that, and we're going to start putting into the standard form. So none of the processes last week had us starting heading into here. Today's process will. Okay, so there's a heads up about what we're doing. We're still writing quadratic equations. We're going to do it by hand today and part of tomorrow, and then we're going to use a calculator or Desmos to do it as the last part of this chapter. So this is a system of equations. If you did the summer assignment yourself, then you'll remember it when I go through it. If you did not do the summer assignment and you kind of just barely got through Algebra 1, you're not going to remember this. If you need to come in after school, please feel free. You have to remember how to do a system of equations. So you know where you're at. Just figure it out. So for a system of equations to solve it, you're supposed to be able to put a plus sign. You line up all of the like terms, like I got A over A, B over B, the result over here, over that. You're supposed to be able to add down and eliminate. That's why it's called elimination. So, did anybody figure out how to eliminate? Okay, it should be a good number of you. What did you do? Okay, yes. So we need opposites to eliminate. And there's lots of ways to make those opposites. Maybe we want opposite A values. So if we had a negative 400 here, that would be an opposite. Maybe we want opposite B values. So if we had a negative 20B here, that would be an opposite. So you all got to figure out what opposites you want to make. There's more than one right way to do this. So I'm going to multiply the top by negative 4, and that'll give opposite A values. So I'm going to distribute negative 4 just into the top. And we're doing a lot of these numbers today. Get your calculators out. Use a calculator every step of the way. Why not, right? You have a lot on your mind anyway. Why not use a tool to help you get your numbers? Feel free. I think it's going to be 23,600. I've been working on my mental math, but you guys use a calculator. All right, so the bottom I'm keeping the same, but the top has been changed, multiplying by negative 4. So now when I add down, I'm going to just combine my terms downward. These are opposites, they're eliminated. We no longer have an A in the problem, and that's why it's called elimination. Yeah, and then you just solve for B. I'm going to use a calculator on the phone.
It's 14,000.
And then I can divide. And I get B is 700. Yeah.
So for example, if the problem was like 100,
Yeah.
and then say 200, and would you do negative 2 times 100?
Yeah. Every time that number is different.
So I did everything correctly. What I did though was I times the top one by positive or and subtracted everything. Can I do that or no?
Yes, you're the second person to tell me. So maybe a lot of you guys are doing that. You could do +4 and subtract down. So that's all about what your algebra 1 did. So I'm hearing quite a few people are, instead of doing a negative, they're subtracting. Same process, really go for it. You can subtract whatever you like. Yeah.
So I did the B value instead and the 5 value. That's also good.
That's good. So now we're going to switch and find A, and you're going to switch and find B, and it should all work out the same. So if you found A first, don't stop. You have to go. You have to find both variables. So here I'm going to write myself a note. Don't stop. You must find the other variable. So I'm going to take this 700 and I'm going to plug it into the original equation to find A. So it's going to be 100 A plus 10 times 700 equals 5,900. And now I can use that to find the other unknown. Nope, just 0. I just had to think of it because I know I wanted something opposite. So every time it's going to be a different number. I could have used -2 and that would have made this opposite of it. So it's a decision you make from the start.
To find A, can I multiply the top by -2?
All right, I hear some really great questions coming in. Go ahead, ask them now. So in today's work, this is like the second half of the problem. So the whole second half of what we do is this. So if you got this down, you got like steps 5 through 6 down on what we're working on today. The difficult part of today's lesson is setting up the two equations. That's what's brand new to you in Algebra 2 is we're going to have to figure these out. Once this is written, solving it is supposed to be something you've practiced before. Okay? So does anybody have a question? Okay, before we're gonna take some notes so you can continue notes right underneath Robert or stand up. But before I go on, I have these page protectors. These were donated for you guys. So I know some of you guys when you hole punch, some of your holes didn't line up well. Maybe it's ripped. Maybe your things got wet. So these are for you to put any of your textbook pages in that are falling out. So please help yourself to these. Every student can take 3 and there will be enough. So I'm pretty sure I think have at least one because at some point one of your pages is going to fall out, right? So feel free to grab those now or at the end of class, whenever you need. And go to page 153 for notes. 153, I believe. I'm going to tell you a little bit of background information The first part of this page is not the work. Okay, so don't write this down. Don't stress out about it. This is not something that you're gonna want to answer a question about it, but it's not the work. It's just a little bit of background information about tables. It says writing equations to model data. When data have equally spaced inputs, you can analyze patterns to determine what type of function it is. Linear data have constant first differences. Pause, that's something you already know. This is what it's talking about with first differences. If we were to graph this table, it would be a straight line. Okay? I know it's a straight line because when I look at how the y's change, they're changing in the exact same way. Down 2, down 2, down 2, down 2. Those are first differences. This is a straight line. Okay, this is background knowledge. This isn't something that you should stress about writing right now. It says if you're looking at a parabola, a quadratic, that means you have constant second differences. So this is a table of a quadratic. You got your x's. Notice that your y's don't change the same way that a linear table does. It goes down 9, and then it just changes by 3, and then it just changes by 3, and then it just changes by 9 again. There's not constant first differences. But there is a pattern that does emerge when you look at those numbers. When I go from -9 to -3, it went up 6. -3 to +3, up 6. 3 to 9, up 6. Those are called second differences. Any table that models second differences is a quadratic function. Okay? Cubic functions have patterns. Quartic functions have patterns. Square root functions have patterns. The more you can figure out looking at a table, the more knowledge you show about functions. Okay? That is background info. That is just starting out today. This is the real work here in example 1. As you read this example 1, and I'm going to totally pause and let the classroom be quiet to give you a chance to read it, I want you thinking about these questions. First off, what is the difference in patterns between linear and quadratic data? Number 2, what data is shown in example 1? It's something about NASA. Just read it enough to know what we're talking about. Number 3, it says try to explain the second step where it goes from these points to these equations. So far, not a single student has been able to tell me how we went from here to here. Actually, one kid did. So really look at it. Try to figure out how these numbers went into here. Okay, you can do it. And then the last step is the text shows the work for A, but how is B found? So I'm just going to give you some time to read this NASA example. Just some quiet reading. Try to answer questions. What's it all about, Cooper?
I'm not the guy for that question.
Did you read it?
Reading it. Process.
What's the next we're talking about here? Did you read it?
Weightless environment.
What? That's true. What is a weightless environment? Yep. Specifically though, it's talking about something that NASA created to let you your weightless environment. What is it? It's an airplane. Yeah. They're talking about an airplane. There's a music video where people are floating around. It's called Zero Gravity. And so, like really wealthy people, they go up and they purchase tickets. They go up in this zero gravity airplane. It's very math. The whole thing is math. You know, that's how they get up there and float. But there's something about it being a parabolic path that makes the zero gravity. It's cool. So notice that the x values are t time, the y values are called h of t, that's just function notation. So number 2, I asked what is the data talking about, and I erased my answer. One is about height. It's about the height of a weightless airplane over time. Okay, I was looking for something like that. Just really to get you out and actually read the words. You know, I know it's easy. You guys have to read textbooks all day long. So really to actually read it. Okay. Now, number 3 is actually looking at the math. How do the numbers go from 10, 26,900, and 20, 30,600 to these equations? You got it?
I understand some of it, of the equation. I understand some of it.
Can you give
Well,
us the sum that you got?
The 21,000 is basically without any time, like the starting time.
Good. Okay. 21,000 right here. Starting height. So the parabolic path begins at 0 seconds at 21,000 altitude. Good. So you saw the c value. This is ax squared plus bx plus c. 21,000 was the c value. Good job. What else do you see?
That since I had it in my head. For the equation that it's using, where the ht equals at squared bt plus 21,000. That the reason I used 26,900 is because that was the height of 10.
You guys hear that? So this is just an ordered pair from the table. Alright, so the y value is sure enough the result. See the y value? Now the x value, 10, is appearing 100 because that's 10 squared. So you saw that too. Good. And then you got 10b, and then you got your c, and then you got your y. So the second ordered pair, 20, this is 20 squared, because 20 squared, x squared, 400. We got a 20 in for that x, we got our c value, and then there's the y. Right. So the more you can start to make connections in your book, the better off you are. Alright, so after that, I believe this is the exact question we did in Bauer.
Yes.
So after that, you're doing what we did in Bauer. They didn't show any of it. They didn't show any of the elimination here. They just said, boom, B is 700, A is negative 11. But they set up opposites and they added down. So like I said, if you guys can learn today how to do this setup from there, I think you got a green light go, you know how to do it. So my answer for number 3, how did they go from here to here? They plugged in 2 ordered pairs, and then you plug in A equals negative 11. Don't worry about answering those if you haven't yet. Okay. So I'm going to give you some steps to help you work through that process. We are going to do number 1 on page 154. And these are the steps we're going to do. I'm going to give you time to read the problem, write the steps down. You can even try starting it before I do it. So I'm not going to jump right into it. I'm going to give you time. I'll read the steps out loud. This is page 154. Steps for writing a function without a vertex or x-intercept. Step 1, you write the model. The model we start with today is ax squared plus bx plus c. Number 2, you figure out the y-intercept c. You plug in the c value. Step 3 is to find two ordered pairs, an x and a y value, that you can plug in to write a system. After step 3, you'll move through the steps using background knowledge. After step 3, you're solving a system using elimination. When you're ready, we're going to do that rock concert question. You finished that. I love the concert. Okay, that's actually just the last word.
So using J, B, and Y, or I mean X and Y are just 2 points.
X and Y is equal.
What is A, B?
Wait, that's what you're solving for.
Oh, I dropped it.
You're trying to find A and B.
So it gets rid of. Yes. So A. I did it different. I always do the A value.
I could also take
Okay, here we go. So it says the table shows the estimated profits for a concert when the charge is X dollars per ticket. Write an evaluated function to determine the maximum profit. Profit and revenue often model quadratic data. So there's a lot of economics and business models where it's a parabola instead of just a straight line. Okay. So you start with writing down standard form ax squared plus bx, or yeah. You start by writing that step 1. All right. Step 2 is to figure out C. Did anybody figure out C? Negative 1,000. Let me look at the table. Yep. Wherever x is 0, you have your intercept. So C is negative 1,000. So I'm going to put negative 1,000 in here. Okay, now I'm going to write a system of equations using any 2 points. That's our next step. So this first order pair, that's going to be point number 1. And then the very next one, I will call point number 2. So let me write those down. Number 1 is 3, 4,100. That's X and Y. And point number 2 is 6, 7,400. That's going to be X and Y. So we're going to plug in for X and Y. So it would be, in the Y spot is 4,100. And then right in the X, we're going to put 3. So first it would be 3 squared plus B times 3 minus 1,000. And then I do that again, and I use the second order pair. 7,400 equals A. This time I put a 6 in, minus 1,000. Okay? After that, you're working these problems. We're doing math from there. After you get plugged in, that's the whole setup. From there, you're relying on your math skills. So I'm going to rewrite this one. Instead of 3 squared is 9, I'll write 9A. And then 3B minus 1,000. And this one shows 6 squared, so I can write that as 36A. Okay, question so far. That's the setup. If you can get to the setup, I'm confident you can get to the answer. Yeah, think about it for a second. I could pause. This is the important part. This is the brand new you've never done before ever in the class. Yeah. So do you know where I got this from? So I started with this. Right? The ordered pair they told me x is 3. So I put a 3 in the x spot, both of them. And then it told me that y is 4100, so in the y spot I put 4100. Okay? Then I'm just going to do the math. 3 squared is 9. And normally we put the number in front of the letter. So I've rewritten it. Okay? And then I just made that 3b. Okay? I'm so glad you asked. Who else has a question? All right, now to do what we did in bell work, you need opposites. So now we have to create either opposite A or opposite B. Is anybody ahead of this and has already made opposites? What would you do, Peyton, to make opposites? Okay, so if we had a 36 here, we could have opposite A. So you can do the top by 4 and subtract down, or you can do the top by -4. That's what I'm going to do, a -4 and add down. Or did anybody create opposite B's and multiply the top by 2? You did that too? Okay, so either way, you can pick. Do you want to make opposite A's or do you want to make opposite B's? I'm going to do the top by -4. And I'm going to distribute it into every single part of this top equation. I thank you for bringing that up. I kind of need to change that. We could add 1,000 over and then do it, but I'm hearing people would prefer just going right to this step. So it doesn't matter. So you could add 1,000 over and then set up opposites, or you can set up opposites from here. It'll all come out the same. I'm glad you did that.
You can subtract 4100, right?
No, we don't want a 0 here. So if you're going to do anything, add 1,000 over. Raise your hand if you added 1,000 before you multiplied. Okay. I'm just going to not do it. Sorry, everybody. We did it. But you guys move forward with doing it and then compare. And then I need to erase that step. Got your calculators out. Do the calculation. All right, A's are eliminated. There's something wrong.
No, that's, yeah.
There's something wrong. Pause not probably my work. I have a mistake in here. Thank you. Yeah, careful about that. I've actually with a different number did that same thing last class, so that must be easy to do. When you distribute through here, negative times a negative is positive. So this is now 3,000, which makes it work out. Doing that same thing back to back. So, Aiden, did you get B as 2,000 in your method? Yes. Okay, now don't stop. You got to go back and find A. So once you get one of them, you have to go back and find the other one. Okay? Yeah, go ahead and plug what you found to the original, one of the originals. You can plug it in here. You can plug it in here. Plug it into one of the original problems that you were in. And that'll give you your last unknown variable. So I'm going to plug it into the top, which was 4100 equals 9A plus 3. And now I know B is 2000. Oh, I should put it in here. Yeah.
No, I solved for A first, so I got just repeating all the time. It's not, it's not a decimal.
No, it's not. It's negative 1000. I mean, negative 100. Who got negative 100? Are you doing what I'm doing? Yeah. What am I doing down here? When I subtract 5,000. Oh, that's 900. Wow. And negative 100 equals 8. But yo, this is the answer. The answer is putting the A and the B in and writing the standard form. So you find your A and your B and then you plug them in. How'd you do on finding B? Okay, and then did you finish it off? So you put it in to this. You put the A and the B in. Because that's what we were doing. All that work was to figure out what A and B was. So the A, this is your answer. So a lot of students will stop at A equals B equals. This is the answer. All right, I've given you 2 of these to try it for your assignment because I know it's a lot of steps, so I only assigned 2.